Okay, a couple things to address. I know one of you had a question on one of the papers. It was C2 and H4. Go ahead and take a look at that. So we got C2 and H4. Okay. So when we're doing these, remember what we want to start with is either the element carbon or nitrogen if they're present, or usually carbon if that is, then if that's not, then move to nitrogen. And if neither one of those are present, then you'd want to move to your non-metal that's the lowest in number. For instance, that's how we get to H2SO4. You want to start with this one, or H3PO4. Carbon and nitrogen are not present, and you want to take the non-metal that's the lowest in number. And that's how we arrive at knowing those are the ones you want to utilize. Okay. So in this case, remember carbon being in column 4, okay? So you might want to try just a single bond, see if that works, between the two carbons. Okay, so we've accounted for both of those. We put a nitrogen on here. We'll just try a single bond. Got a pair of unshared pairs of electrons. That's what I was trying to say. 1, 2, 3, probably 4. Oops, want a triangle there. 5, and then notice we've got 4 hydrogens to contend with. So it looks like we could do a hydrogen here, there, 2, 3, and 4. And notice that doesn't quite do it. It gets us close, okay, but just not quite there. And then typically, hopefully when you get to this junction, you can see what's not working to see what actually can work. Okay, so the single bond is not working between these carbons or nitrogens. So it looks like, to me, what would look the simplest, okay, is possibly trying a double bond between that of the nitrogen and a carbon. Because I think we're all right here, because notice how close we got. So let's go ahead and try this. Okay, and then here's your second carbon. Oops, that's not quite right. We said a double bond. So that means we've got to put that down there. We got our 4 X's for this carbon, and between that and the nitrogen. Okay, so 1, 2, 3, 4, 5. Now we've got 4 hydrogens to contend with, and it looks like we can put one here, 2, 3, and 4. And we're still no closer yet. Okay, so maybe that was NH5 on there. I think that's what it was supposed to be. So put that 5 on there. I think that solves that problem. Now we've got 8 around each and every one of them. Okay, so next, let's maybe go ahead and look at something like okay, so CH2O. We already know that we're going to be starting with this carbon. Okay, so if we go 1, 2, 3, 4, put a hydrogen here, and I can already see that we're running into problems here. Yeah, that's nowhere close. So a single bond is not working between these. So let's go ahead and try a double bond. Okay, so now we've got our oxygen and our carbons done, and then here is our hydrogen. So that is complete. So I think a lot of times what happens, the more we practice these, the better that you get at them. So let's maybe go ahead and do one more as an example, and then that would be it for today. Let's maybe throw one in. And I think what we had said yesterday, we're still going to continue to review tomorrow. I just want to do one more problem, and then we'll have that problem quiz on Friday. So let's try one that has a negative charge to it, and that will be it for today. So So again, when that negative charge pops up there, that's telling you that you've got one more one more electron than what you would actually have. So if we try single bonds again, okay, and then if we try putting an oxygen here, and then we have another oxygen. There's no place for that to bond. So as we can see, the single bonding is not working. So let's maybe try putting a double bond between these two. And who's to say that we can't double bond on both sides? Maybe just give that a whirl once. And upon doing so, okay, and then we've got a hydrogen, and then there's no place to put that last hydrogen. So that is not quite working. So let's maybe take him. Oh, no, we wanted to keep that. And then okay, and then we got 3 hydrogens. We can put one here, and then 1, 2, 3, 4, 5, 6. Notice that we're 1 short on this oxygen, but we got that one to contend with, so just make that a box. Therefore, we've got an octet of 8 around everything except for that of the hydrogens. Okay, so that was nice and short. That's why we wanted to keep it. So again, just something a little work on today. We'll review again tomorrow, problem quiz on Friday. We'll catch up to you next time.